Okay, hi. I hope you guys can all hear me. So I'm Julia Signell. I'm a developer at Anaconda. I work on some of the different open source tools that we have going on there. So I work on intake, and most of my time I spend on the HoloViz tool. So we'll be talking more about that later. This talk is not about a particular tool or a particular content area. It's meant to be more a talk about how to do, about your workflow and how to ingest data, get it in a workable shape, and visualize it, even large data, and how to deploy dashboards. So hopefully we'll be able to cover that in 40 minutes or whatever. I'm going to be talking about a lot of different tools, mostly intake, panel, and hvplot. But all these other tools will be used either behind the scenes. I'll try to call it out when it's happening. But you don't have to use all of these tools. You can take one. They're designed to work well together, but you can just take one if you want that one and use it on its own. That's totally fine. We won't be sad. So this talk is going to have 3 different data sets. The first one's going to be Anaconda package download data. So that's tabular, time series data. It's categorical. It's stored as Parquet files. It's too big to fit in memory. And it's just all the downloads that happen of all the different packages from anaconda.org. Satellite imagery, which is raster data. It's georeferenced, stored as GeoTIFF, and then locations of trees in Philadelphia, which is also tabular. Georeferenced, stored as GeoJSON. It's like, I think it's 100,000 trees or something. So the first one we're going to talk about is the Anaconda package download data. So this data is publicly available. It's in an S3 bucket. It's daily Parquet files. And you can find, there's a link to it here. And I'll post these slides. They're up online if you want to. That URL is probably small for you, but I'll put it on the Slack. So they're at this URL, this repo. And in this case, we're going to be talking mostly about intake and panel. So we're going to be making this dashboard, which is a panel dashboard, and it allows people to interact with your data. So I meant to say this at the beginning, but the point of this talk is to explore your data, visualize it, and then to allow other people to explore it who maybe are less technically advanced or maybe just don't want to spend the time digging into the code, but you want to expose some features that you think are interesting to other people, allow them to explore that on their own, but in this guided dashboardy way. So that's kind of the motivating reason for this, is that you might be comfortable getting in a notebook and exploring it, but for others it's often easier to put it in a dashboard. So panel is a tool that allows you to do that fairly easily. So before we get to that though, we have to start with loading in our data. So we're going to do that using intake. Intake is a data cataloging tool. It provides a layer of abstraction between the data and the user. So that allows the data provider to distribute the data, and the user doesn't have to know that much about how the data is stored and where the data is stored, and all these things that ultimately they don't really care about. It captures the dependencies of a particular data set. So you can capture that all, and we'll talk about that more when we get to that part. And it reduces the copy and pasting between notebooks. So instead of having a top cell be this huge long pandas read CSV with all these different options, you just have a simple one-liner from intake, and you don't have to think about it. So we're going to start by talking about that in more detail. Okay, notebook time. So this notebook, as I mentioned, is bigger. Is that good for people? More? Okay. So this notebook is available in the GitHub repository. So we're going to start by using dask, and we're going to show how you can read the Parquet file using dask from S3. This is all well and good. You can use globs, it's fine. You can do a similar thing using intake, just using intake.openParquet with the file and the storage options, and store it as a dask array. So the output from these two things are identical. So that doesn't seem very useful, right? That's fine. It's the same thing. But the real benefit that you get from intake is when you store the metadata and the options that you're feeding into this read command in a catalog. So this is what an intake catalog looks like. This one's a little involved, but basically all they need to have is a URL path where the data is actually stored and the type of driver that we're going to use to read it. So that's kind of the most essential part of this. And then this one also has some different user parameters, so like year and month. And then it also has this cache. So we're going to cache the data locally so we can access it more easily. So now all that data is abstracted into a YAML file, human readable. You can distribute it. So it's up online. So we're actually pulling it from GitHub directly. And we can open that catalog. And then we can get the data for the whole month into a dask data frame in just a one-liner. So we are looking at that catalog now because we're talking about how intake works, but from the user perspective, they never need to really look at that catalog. Like, they're happy. They've got their data for the month. So you can also read straight to pandas using .read instead of to dask if your data is small enough to have that work. And then the other method you can use is you can package your data as a conda package. So in this case, you guys can go, if you want, conda install this package from the intake channel. And then you don't have to mess around with reading the catalog at all. You can just, it'll be in the intake built-in catalog itself, and you can just call it directly. So in this case, they don't need to know the URL. They just have the data package in their environment, in their conda environment, and then they can read the data in the same way that we talked about above. So there's a couple of different ways to use it. You can choose which one best suits you, or not. But this one I think is particularly interesting because you can store all the dependencies. You can store the dependency on fastparquet or dask and intake itself in that data package, and then you just have it. And it's really probably the most straightforward way. And the data, I should mention, is still on S3. Like, this data is not in the package itself. There's just a link to it. And then once you have the data frame, you can just do the normal things you are going to do with your data. You just carry on with your life. Like, it's no different. It's just a way to load in data. So you can, you might want to compute how many pandas, how many downloads of pandas there were from the Anaconda channel or something. Or you might want to look at Python 3 versus Python 2 usage. So you can explore. This is a binder link on the repo. You can do what you will. So now we are going to talk about creating the dashboard. So panel is a relatively new package that we've been developing in the HoloViz ecosystem. So it provides, but it builds on Bokeh, and it renders in Bokeh. And so it has this really solid foundation. So it's a relatively new API, or set of APIs, but it has a really strong basis in Bokeh. So it provides APIs for interactivity. We'll talk about some of those. There's a bunch of different ones. There's pretty complete panel docs that you can find online. You should Google Python panel, not just panel. It doesn't do anything if you don't put that. But so it allows others to explore your data without writing any code, which can be really helpful. And it also doesn't make you write any JavaScript, although we are going to write a little JavaScript in this case, but you don't have to. Okay. So in order to create the download dashboard, we're going to first load the data using intake. This is just a little get the last month thing. And then this is our class that we're setting up to use with panel. So this is one way in which you can use panel. It's a parameterized class. So we're using this in this case because we have a bunch of state that we're going to want to keep track of. So that's a really good use case for a class. So we want to keep track of the package name that the person has inputted, the version, and then there's like the grouping that they have chosen on their dashboard. So those are going to be things that the user is going to select. Then we're going to store them on the class, and we're going to show various outputs based on what they've chosen for those parameters. So we can go into this more later if we have time and you guys are interested, but these are basically a bunch of methods that we're setting up, and they either do something or they return something, and they are all decorated with this params.depends, and they're decorated with particular parameters that the user will define. So this one updates the data that we're going to use, so it subsets the data to just be about that one particular package that they've selected, and it depends on the package attribute. Okay, so there's a bunch of these because I got a little involved with this. And then you can set up a layout for how you're going to display all these parameterized objects. So when you have the class has these different properties, and then we're going to display them all in this kind of like row column framework. You don't have to use this row column way. There's other ways to do this, but it's just when you make a dashboard and then keep adding to it, you often end up with this kind of thing. So now we have our dashboard, which we can view in the notebook right here. You can try a different package, and it'll re-render. You can group by different things and change the bar chart. You can select which version you want and only look at that version. And this is the type of thing that is kind of like useful to package owners. So this is something that can be used without accessing the notebook by serving this dashboard at a URL. So if you go to the GitHub repo, you can find a binder link to the app itself, and it'll drop you right into this app running on Binder. Okay, so now we are going to jump to the next case study, which is satellite imageries and locations of trees. So I said we'd do 3 different data sets, but these two I'm going to do together because they overlay on top of each other nicely. So in this one we're going to be mostly talking about hvplot. So we're going to be working up to creating this dashboard, which actually works statically. The one we just looked at a minute ago works if you have a running Python kernel because it has to subset the data. And that can only happen in Python. But this one we're just going to be doing sliders and adjusting which layers are turned on and turned off. So that can be done using JavaScript. And that allows it to be served as a static URL. So you can find it at this link. It's just my GitHub and then heat and trees. And it's a fully functional little static thing that you can mess around with. And it doesn't have a running kernel. Okay, so we're going to be mostly talking about hvplot in this section. So it mimics the .plot API that you get in pandas. But instead of generating matplotlib output, it generates hollow views objects, and they're rendered in bokeh. So that's a lot of different names of packages I just said to you. But basically, the result is that you can do a lot of different grouping and aggregating and overlaying very easily. That's what hollow views gives you. And then bokeh gives you the ability to zoom in, zoom out, have hover tips, and just have this really nice interactive experience on the JavaScript side. So it also integrates with GeoViews and datashader. GeoViews gives you the georeferencing, and datashader allows you to aggregate to the pixel so you don't overplot your data if you have large volumes of point data, or if you have really dense raster data, you can aggregate to the pixel as well so you don't crash your browser. So right now, hvplot supports pandas, GeoPandas, dask, X-ray, streams, and NetworkX, which I always forget to include. So we'll start by looking at just the raster data. So this is Landsat imagery that we're going to be looking at. So this is the imports. We're going to import it using intake. And just a little background on Landsat imagery. It's distributed in these swatches. So there's paths and rows, and each path row is called a scene. And those scenes are captured at a particular like frequency or a particular cadence. So you might get like one every month or something. And they're all publicly available on Google Cloud Storage and AWS. S3, I mean. So when you take, each Landsat scene is composed of these different frequencies, these different bands that capture particular information about the Earth. So for this case, we're going to be looking at the land surface temperature. So we're going to calculate the land surface temperature from a couple of these different bands. So for that, we're going to use the red band, the near infrared, and the thermal infrared bands. So we're going to be using those bands, and we're going to be doing some calculations on them. And then we're going to be getting land surface temperature from that. So we can get the intake catalog, which we'll read here. So this is what the intake catalog looks like for this case. So it's a Landsat band. We're using the raster.io driver. So that allows you to read in raster data really easily. You can see all these geotiffs. So we're going to take the 4 bands that we're interested in, the 4, 5, 10, and 11, and then we're going to concatenate them. And we're going to allow the user to specify the path, row, and product ID that they're interested in. So in this case, I'm choosing the area above Philadelphia for this particular date that was very hot, because I don't think I mentioned what we're trying to accomplish in this particular case study, but we're trying to look at the surface temperature and compare that with the color of roofs and then and the location of street trees to try and see if there's a relationship between surface temperature, roof color, and street trees. So the hypothesis is that dark colored roofs are hotter, and if there's more street trees nearby, that mitigates that. So we're going to get a particular path, row, and product ID, and we get a data source from intake, and then we can read it into dask, the same way as we did before of using dot to dask. So now we have an X-array object, and the X-array object isn't yet read into memory. Actually, it is. But it doesn't have to be. It can also be a dask array. And then we can subset to a region of interest. So since this is geodata, on this X-ray object, read in with raster, there's a coordinate reference system. So we can take that coordinates reference system, and we can use Cartopy to convert it to a CRS object. And then we can read in GeoJSON of the neighborhoods in Philadelphia to subset to that area. So here's this is a GeoJSON that contains all the neighborhoods. We read it in using GeoPandas, and then we get the bounds, and I'm going to skip a couple steps. We get the bounds. We just take that chunk of the raster, and then we can create a plot of all of the different bands. And using hvplot, we can just say we want X on the X-axis, Y on the Y-axis. We want our particular coordinates reference system that we've defined above. We can say we want our color map, our log scale, and then we can also create a plot of the neighborhoods of those polygons. And we can overlay those 2 plots using the star operator, which is just a HoloViews terminology for how to overlay plots. So now we've got this plot where we've got all our neighborhoods, and we can see that we have the correct area, so we can move along with our analysis. We're just going to be looking at the raster data now. So first we're going to calculate NDVI. So this is the vegetative index, so we can tell where this is the first step for calculating land surface temperature. So it's a pretty simple calculation. You just take one band, you subtract it from the other. So X-ray allows you to do these calculations really easily because it keeps tracks of the labels for you. And you can just do your math, and then you can plot it using this .hvplot directly on the X-ray object. So now we have our NDVI, and then we can calculate land surface temperature. So there's a couple calculations here for land surface temperature. I just found them online. They seem pretty straightforward and well understood. So once you've calculated land surface temperature, you can plot that. So you can calculate land surface temperature for band 10 and band 11. So here we've plotted them, and we've, in this case, we've rasterized it. So instead of, this is a datashader command, so instead of plotting every single point, we're taking the mean of each pixel, and we're plotting that instead. So that makes it significantly faster. And then when you zoom in, it'll re-render, and you can see more resolute images. So you don't lose anything really. It just makes it easier to see, or to actually render. So we'll just take the mean of those, and then we can plot it over some imagery, some tile service imagery. So it's easier to see actually when we use the thresholded one. So we can take just the mean temperature and look at the values that are over 90 degrees Fahrenheit, and then we can look at just those values. So over here we have those values, and then we have the same plot linked with the zoom, and you can see the area it's the same exact data. It's just that it's easier to see it against a white background, and then you can see the imagery, the tile imagery underneath re-rendering. So that's already like pretty helpful way to explore this data, but I thought it'd be even more nice if instead of having the threshold just fixed to 90 degrees Fahrenheit, if instead we had it be something that the user could control. So that's what we're going to be trying to get to in our panel, our dashboard. So, but first we're going to talk a little bit about street trees. So street trees, this is something that the city of Philly did. They just had some interns locate every tree, every city tree one time. So it's getting more outdated, but they did this once. And so I think it's 100,000 points. It's distributed as a GeoJSON. So you can load that right in using GeoPandas. And then here I'm just plotting 10,000 of the points using GeoPandas because it's kind of slow. So you can use hvplot directly. You can set the X and the Y, the geo is true, and I've data shaded it. So instead of, this is another data shader command similar to rasterize. So we're just counting how many trees fall in each little bin. And in this case, I've made it slightly bigger than a pixel. So this is street tree density. And then just to make it faster for the panel, since they distribute it as GeoJSON, but they only filled out the geometry field, so they only give us lat and lon. So I just transformed it into a regular data frame with latitude and longitude, and that makes it just a lot faster. So then we have so that's the street tree data. And then we save it off as a Parquet file to use in the next. Okay, so now we're going to be talking about creating the dashboard. So we're going to be using we're going to load in the data that we computed from our first notebook, which I stored off in a ZAR file. It's just a good way to store X-ray objects. And then the tree data, which we stored in a Parquet file. And we're going to make a special little color map that only has reds and extreme reds. And then here's a little function that creates a thresholded plot, and it takes the mean temperature it looks for the values where the temperature is greater than the threshold, and then it calls .hvplot on that with these particular options. So it has tiles underneath it, these Esri imagery tiles. It is georeferenced. It has a special color map. It's rasterized, so it's faster. So that function will return a plot. And if we call panel.interact on that function and pass in an upper, lower, and an upper limit and a step, then we'll get a widget. So this mimics the IPyWidgets API, if you guys are familiar. So it creates this widget, which we can toggle and control our threshold. So you'll see when I drag it, it kind of flashes because it's re-rendering the whole plot. So that's kind of a limitation of this approach. This panel.interact is like a very fast way to get a widget if you want a widget. But it recomputes the data every time because we're subsetting to below the threshold. It re-renders the whole plot, and it uses a Python kernel, which in this case we really don't need. It's kind of overkill. And we can get it to work in a static version just with a tiny bit of JavaScript. So first we're going to define the plot above. So this is similar to what I just did in that function above. And then we're going to use a clipped color map. So instead of subsetting our data, we're going to say just anything below our color map or above our color map we're going to make transparent. So that's what this looks like. So and this is actually kind of nice because you still get hover values for all the stuff that's outside your color map, because there is still data there. You just chose not to look at it. And then the next step is to use JavaScript linking to link. This is like the weirdest part probably of this talk. But we're going to link the top of the color map and the bottom of the color map with the values that you choose on your widget. So you just, this part's the JavaScript, and you just link that up, create a widget with a start and end value, and then you link it to the color mapper on the plot object. So now you'll see that when you drag this, it just re-renders, or it just changes. It's very snappy, and it doesn't require any changes to the data underneath. It's just changing how it's rendered in JavaScript, and you can see that color map, that color bar moving around while you do that. So then we'll add in trees. So this is the same tree plot that we did in the last one, and then we just add a toggle to turn that layer on and off. So it's the same thing where it's just a simpler JS link where we're making the whole plot invisible basically. And then we'll make a base layer. So the tiles, where we're going to use we'll use this widget that will choose between all these different tile source options that are exposed in GeoViews, so that we can pick which tile we want for our base map. So in this case we have Esri imagery, but you can choose other ones. And this one's boring at this extent. And then you can add more interaction, like some little alpha sliders. And then this is the actual dashboard that we are creating. So we have a row of, the first column is going to be the threshold slider, the alpha slider, base map selector, and then we're going to have the plots, which we're layering on top of each other using this star operator. So we're going to have the temperature plot, the tree plot, and the base map plot. And then we're just assigning it to a variable here, and then we can actually display it. And you'll see that you can interact with it, and it's all just the same as we were looking at originally in that static page. So once you have done that, you can save this as an HTML document. You can, and all of the parts of it will work except for the tile selector, because that is actually needing a Python backend. to change between the different tiles. But you can even embed that if you want. Just embed a couple different options for that. So that is the most of what I wanted to talk about. There's some parts I glossed over, so I want to just let you guys maybe tell me if there's a particular part that you'd like to see in more detail. I can talk more about the parameterized class way of doing things, or anything else. I want to open it up.
So I guess there'll be something like a Q&A?
Yeah, sure.
Is there a way to use this without having Conda?
Yeah.
Oh, how?
You can pip install it.
Oh, all is available on Pip.
Yeah, some of the geo stuff gets a little wonky, like, but I think you can even pip install the geo stuff. Yeah, but if you just want panel, absolutely. If you just want intake, absolutely. It's just some of the deeper dependencies can get, there's some, the geo stuff in particular is hard to do without Conda.
Thank you.
Yeah. Put on something nice.
Thank you. I'm new to HoloViews, and as I understood, the primary utility of using HoloViews is enabling you to layer those plots. Is that correct?
So HoloViews is the underlying library that allows you to do the hvplot. So when you call the hvplot, that's just a thin wrapper that goes to HoloViews and asks HoloViews to do a bunch of stuff, and then returns a HoloViews object. So the way that I mostly use HoloViews, because I'm a heavy hvplot user, I like that interface, is to do the overlaying and to do the linking of side by side, and to get extra options sometimes. But HoloViews has its own whole ideology about how data should be stored and how to make it really easy to visualize data. It's all very laid out on the HoloViews site, so I encourage you to look at that, and it might appeal to you. For me, I was more comfortable with the .plot API, and it just works better for me. But HoloViews aspires to let you just annotate your data, and then it should be able to visualize itself, is the HoloViews premise. So it's more than that, but that's just how I use it.
I think it's for
mic is for the.
I think, yeah.
Thanks for the good talk, Julia. So can you maybe explain the relationship between the hvplot systems and all the HV stuff here and voila, and how those are going to play together or do play together?
Yeah. So voila, for people who maybe aren't familiar, is the Jupyter dashboarding solution. So panel is a dashboarding solution that can work in Jupyter and also works outside of Jupyter. And voila is a Jupyter. It was developed by Jupyter folks, and it works in Jupyter exclusively. Right, I think at this time or very soon, panel can work in voila, and all the HoloView stuff can work in voila. And we're trying to get the other direction working as well. I don't think that's quite done yet. So the goal is that everyone can just play nice together and people don't have to worry about it. It's not quite there yet. Same as IPy widgets is the same deal. As we would like to have IPy widgets included in our dashboards, and we're very close to having that be a reality.
Any more questions?
Thanks, this is great. Hypothetically, let's say I'm terrible at JavaScript. Hypothetically.
Yeah, right.
Is there a convenient list of the things that are most commonly done to add toggles and stuff, or some of the JS?
Yeah. So okay. So I talked about a bunch of different packages in this talk. So a lot of them fall under the HoloViz umbrella. And so if you want to learn more about all the Viz things you saw, that is HoloViz, and you can just start there. It's Viz with a Z. It matters, actually. So it's just holoviz.org, and you can start from there. But they also all have their own package-specific docs. Panel has very good docs, and there's a whole section about JavaScript linking where it goes through the most common uses. If you're really getting into it, you just have to do a lot of printing is the main thing that you have to do to figure out what exactly you have to work with. And once you do that, it's fairly straightforward to figure out what's going on.
Can you talk more about the live updating on the JavaScript side? Can you talk more about the live updating of the content that the widgets are displaying? Because this looks really well done.
Yeah, so I mean, it's just changing. So Bokeh has a Python side and a JavaScript side. And in this case, we're just fiddling with the JavaScript itself and controlling it with this slider. So it's just changing what's actually being viewed. So it's just how every website works, basically, right? So it doesn't have a Python instance, so it's very quick.
Could you stream data, for example, and have the map update?
I'm not entirely sure about streaming it. I guess it depends how you are getting that data in. Most of the examples that I've seen with streaming data use the dask streams library, and that would require Python. Yeah.
Any troubleshooting tips for intake, what to watch out for? Because I'm excited about using that.
Yeah.
And I feel like it's half my battle if I can get data in. So I don't know, do you have
Any troubleshooting tips for intake? Well, definitely reach out to us. If you have, seriously, we're on intake, there's a getter, don't hesitate to do that. We want to know what people are struggling with. We want to know what people are using it for. So please do that. Or if you think you've run into a bug, file it. Also, if you have suggestions, there are docs on intake, but we're always open to suggestions. If you think that there's something that you can't figure out from the docs, and then you figure it out, great, open a docs PR, or tell us, write up a GitHub issue or something. Yeah, it's hard to say what the debugging techniques are, other than a lot of times I start at the top doing an open parquet or open Xarray or something, and before I write the catalog, just get all the arguments fleshed out that way.
How does this compare to Tableau?
Tableau is very drag and droppy, right? And it's very slow. Okay, so maybe it's not as slow. No, I mean, I don't think we're really quite aspiring to be Tableau, but the idea with this is that you are creating dashboards for people to interact with your data. And you customize that experience for them. I don't have much familiarity with Tableau, so I can't probably do a good comparison. But my understanding is also that Tableau is mostly for only tabular data, possibly. And we really have a almost maybe too strong geo data influence in our team. So we are very attuned to the needs of n-dimensional data. We work a lot with Xarray data, and we've really put the focus on that. So you can do tabular data. We try to make it as nice as possible, but you're not confined to these tidy data sets. You can also have other stuff, because you probably do. Yeah.
Right.
So I've seen that there are also other backends beyond Bokeh that are supported. Are all of those other backends also servable?
Yeah. You can put any type of plot you want in a panel app. That's your question, right?
Yeah, like you also support Plotly as a back.
Yep, yeah, you can put any type of plot you want. Right now, hvplot only supports bokeh, but there's no reason for that, it's just time. But HoloView supports Plotly, Matplotlib, and bokeh.
All right, Julia, thank you very much.
Thank you.
Very much.